Alright, welcome back everyone. Good morning. In today's video we're going to be looking at making the cross brace on the back here. And the reason we're going to use the AFX tool, and the reason that I wanted to look at making this part is just to shift your thinking and the way you view, the way you can use the AFX tool. So while I was making this part, I realized that I didn't need to put in sketches and datum curves, etc., to actually make parts with the AFX tool. You could define them off other edges. So maybe I'll show it on this side. The inner plate here, this one, is actually referenced off the edge of this plate. And using the move tool in a few simple clicks, like 2 clicks or something, we were able to position it exactly where we wanted it. And one of the other things I'll show as well is the copy tool, using that. So there's some pretty good stuff in there. So what I've got prepared here is just a frame, and there are some points in here already. And I've got a sketch right here which is on the face of these tubes, and so we're going to imagine that this is where we're putting our rear cross brace. This box is our chassis and we're putting our cross brace here. Alright, so to start off I'll put a little sketch. We do need some datum curves to start with. So I'm just putting a sketch on that datum plane, and I'm selecting the points that were there in the chassis model as references. And remember, I'm using the point tool up here, not the point tool in the sketching tab. We want the point tool from the datum tab. And then I'm going to put a set amount down. This little button here, you can click and it refocuses your view in plane on the sketch. I'm going to put a point there and there. And I'm going to going to dimension this point away from our original point. Now in the actual cross brace, I think it's something like 120 mil. We'll just go 200. Nope. We'll go 150. And you can see this one was constrained to the height of that one, so it's all good, but we still need to dimension one of these ones. We'll make that equal as well, so 150, there we are. Alright. Now we could actually probably make a frame member using just the points, but we're going to use, we're going to make them datum curves. Cross brace sketch, again intrinsic naming of stuff. So grab the datum curve tool, select the points. If you've watched the other videos you should be up to speed with this. Making sure here we've selected the point on the plane. And making sure that you select to make the datum curve as a straight line, not the other option. The curve on, for this anyway, for this application. Alright, so now we're going to go, going to group this, rename our group, and we're going to call it cross brace 3D sketch. It's loosely what it is. And then we're going to create a sub-assembly. We're going to call this cross brace. Yep. And we're going to position it in free space, then set it to be default, and its coordinate system is now our default systems. We're happy with that. Now we're going to make this our active part, and then we're going to come into the framework tool and we're going to go new profile, and to start off with, we're going to put our plate in, and we want, interesting the way it defines that. Might go back to rectangular beam. And we're going to pick, we'll make it fairly similar, so 40 by 2 or whatever I made the other one. Cool. And we're going to make sure we select the datum curve we want. It's going to say there's no project. We're going to type a name, cross brace. Cool. All right. So here we are. We've put it in. That's not how we want it. So we'll first rotate it. And now it's still not how we want it because it's clipping inside this tube. And now we're going to select, place it on the far right edge of the thing. It didn't seem to update. Maybe this one. There we go. All right. And now we're going to middle mouse and repeat. We're going to rotate and then click. Just going to make sure. Okay. Cool. All right, so there's our outer tabs. Now for the cool part, we want, so with the cross brace model, what happens is this outer plate gets welded to the chassis, and we've got a 10mm gap here to allow for a fillet weld to run down this side. It'll run down both sides, but we want to then bolt this cross brace on. And so this plate here gets welded to the cross brace, but bolted to the chassis via these tabs. So we have this offset. So what we now want is this next plate. So the super cool thing in shifting your view is there's an edge here. But first of all, I now want 30 by 2 plate, 30 by 2 to get our offset for the weld. So there's my edge. I'm going to rotate it, and you can see it's now in the direction we want, but it's not aligned where we want, and it's also clipping inside the tube there. So if we pick this one and this one, eventually one of these should get us, there we go, what we wanted. And theoretically, with one click or 2 clicks, this plate is now exactly where we want it. So now that we know the right one, we should be able to do it rather quickly. So here, rotate, done. And now here I can select there, rotate, and I'm going to guess that it's that one. Yep. Cool. Rotate. And so, you know, that saves 5 minutes or so fiddling around. We didn't need to have, didn't need to put in extra points and curves. All right. So now if we look at our model again, our model had holes and rounds. So holes for bolts and rounds just so there are no sharp edges. It's good practice to remove sharp edges on all your fabricated metal parts. So instead of having to make a custom profile for every time we want to you know, make a plate with holes in it, what we can do is, now that we have our plates where we like them, we can select this one, we can open it up as a part, because again we're in the assembly level here, And now that we've opened it as a part, we can edit it. So now I'm going to put an extrude on this face. I'm going to select my references. I'm going to guess that this is the outer edge. May not be. On this plate, it doesn't matter because the way the thing was designed is that this one is in the middle. So I've just quickly thrown in 2 holes. Now I want to use M10 bolts, so I'm going to make these 10.5. I think that's what I did before. Or did I put M8s? I put M8s. So we'll make this an 8.5mm hole. That's probably enough, usually enough clearance to get an 8mm diameter bolt through nice and easily. And we're going to dimension these, not really fussed for the tutorial. So we'll just make this 40. And we'll dimension here to here as 40, and that leaves us with something in the middle that we're not fussed about. Alright, now if you've been watching Tim's tutorials, you'll already know how to do an extrude, but I'm going to select to extrude to the next surface. I'm going to select the surface on the other side, and I'm going to remove material. There we go. Alright. I'm going to save that, I'm going to close it, then I'm going to come here and regenerate it, and sometimes you'll see your view goes like this. I'm not really sure how to easily fix it without just restarting Creo, so that's how I fix that. So we're just doing that now. Alright, so we're back now. We have our expanded menu again. So I'm going to turn off all this stuff because we don't want to see it. And then as you can see, we now have our plate here with some holes in it, which is what we wanted. And now we're going to open up the smaller plate and we're going to do the same thing and put some holes in it. So we're going to do an extrude on this face. We're going to guess that this edge is the right edge. Now on this one, we need the holes to be something like 15mm down the side, I think. So we're going to put a center line in here, and then we're going to dimension from the center line to this edge. I'm going to call you 15. That does make sense. Well, we'll just put them in the middle and see where they come out. 8.5, so we want the bolt, same bolt to go through. We need them at the same height, so 40, and then dimension 40 and 40. Remove material and extrude to the next surface. There we go. Right, and we'll save that. And then we can close this. And now you can see we have our holes, and they're off a little bit by about half a diameter. So we'll just quickly edit that. Oops. Open that up as a part again. Go to our extrude, edit that. Dimension it to be 20. Why don't I make it in the other one? And 15. Maybe it was meant to be offset on the first one. That makes sense. So I'm going to cancel editing the 30mm plate, and I'll edit the 40mm plate. I haven't named my extrude anything useful, so that's something to remember. So placement, edit internal section, and then I'm going to dimension you from here, and it's going to complain. That's fine, and I'm going to call it 15, and I'm going to put a, and I'm going to put a center line, and then I'm going to put the point on the center line using coincident coincident the center of the circle to the center line, and delete the point on entry. Cool, that didn't do what I wanted. Just going to delete it. Put in the center line. Put in our other circle, make sure it's equal. Dimension U to be 40. Alrighty. Now, there we go. So they're all lined up. And sometimes your model, when you've updated parts and things in your parts in your features or whatever, your assembly level view might not have updated, so you might need to hit the regenerate button up here. But in our case, it's fine. So now we have these two, how we want them. We didn't put the rounds in, but if you were to do that, I'll quickly do it just in case it's not covered in any other tutorials. But very simply, here's the part, I have the holes. Now on this plate, I want rounds on all edges, so I select the round tool. I'm gonna make it a 2mm round. For these parts, it is arbitrary, so we're not really fussed. And now I'm just left clicking on the edges that I would like to be rounded. So I'm just picking the corners. And then middle mouse click to be finished with the tool. And you can see it's updated straight through. So now we have the parts how we want them. So we will now use the replace tool. Sometimes the copy tool, because we're using, I think, the copy section. So there's an option here, replace profile by a copy of an existing profile instance, or replace copying a section of an existing profile instance, which seems very similar. One of these two will be the one that we want, and we will find out very quickly. So I've selected the first one, we've selected the reference, and now we're going to select the thing to replace, and you can see it's kept our extrude. How great is that? So we could have made a whole bunch of different, interesting features and then easily copied it around as many times as we needed. So, if you're making pickups, you could make one, spend the time making one, and then copy it across to everything else. And if you dimension the stuff on your part appropriately, you can always have the features only appear at the 40mm, say, at the top of the part. So that would work on a pickup, for example. Now, while I have the reference profile selected, I'm just going to go around putting it on all our outside ones. Now I'm going to left click reference profile, and I'm going to select the 30mm plate, and I'm going to copy that onto the other 30mm plates. And within a few seconds, you've got all your holes where you want them, and your part's looking great. One of those copy features would copy the profile, but none of the features put into it. Useful, I guess, if you don't want to have to go back through and select things. Yeah, so while I'm here, I might just quickly show you the modify ends, so you can see we've got the cross section of a beam here. This shows you what we're actually editing. So you have to select the tool, then select the edit pencil, then select your item. And to get a quick gauge of what we're doing here, you can see this option has put an angle on that. We'll reset that. But you can see, even though I selected this edge, it's editing the cross-section edge up there, because that's how the cross-section, that's how the framework member is defined. It's defined along this edge from a point here to here, and we just nominated a cross-section of, come on, Korea. We nominated this cross-section of 40mm by 2mm, sorry. This top surface there we go. We nominated this cross section, and so Creator says, all right, no worries, I will place that cross section along the length of the datum curve that it's referenced to. So remember, our datum curve runs up and down here between these 2 points. All right, well, I think that's everything for this tutorial. I'll make in a moment, I'll make a short one, just a reference one on how to use the fastener tool. It's super quick and easy, so make sure you check that one out. All right, thanks for watching, guys.